and they're kind of paired up with the ones that they go with. When you're up here with this screen, you can kind of pinch zoom. And I'll just have a paper copy of the whiteboard, or sorry, a paper copy of the worksheet off to the side. The pens are kind of flaky, so I've got 2 of them here, but you should be able to mark up on here if there's anything we ask you about. Okay, you can just mark up on your board. So with that in mind, let's bring up the red group. If you want to chat with us about, here you go, give you a little more light. Chat with us about 2A, where we've got moving car rolling up a hill until it stops. System consists of the car, the road, the earth. The engine's off and the car's in neutral, and there is no friction. This would be a good time for you to have the worksheet out and jot down some things for the video work working on. All right, take it away, Red.
Yeah, I think that. Yeah. Yeah, we just.
Do you have to do anything to write?
Okay.
Where do we start? Ready?
Yeah?
Okay. So the car is moving up the hill, and the system consists of the car, the road, and the earth. So that's what goes in the circle, the system/flow circle. At the beginning, it doesn't have a spring or anything, so there's no EE, and then it's already all the way down, so there's not any EG, but then it's moving, so you're going to have some boxes at the EK, and then for position B, the car is stopped, so you're not going to have any EK, but now it's at the top of the hill, so you're going to have EG, and then there's still no spring, so there's no EE, and then there's no friction, so no EDIS. So then you have the position A, there's only EK, so you have EK at A equals EG at B.
So can you, just because it's kind of hard to see, can you rewrite that equation for us in that blank space on the whiteboard? That's not.
Maybe? No.
All right, just because we're notoriously reticent to ask questions out loud, I've got a Paradex fired up back here. ZFOXW. Part, could you be the hero and in that joint PD box up front, can you write ZFOXW?
There's a marker. Hard. Turn it on.
Not trying to be high ratio, sorry.
It's okay.
All right. Now, unfortunately, 2 of our better paired deck question askers are up front, but if you got questions for this group,
It's me.
ZFO. I said 2, I didn't say the only 2. The 2 of the more regular questions. ZFOXW.
Yeah, because
I thought he meant.
I didn't say which 2. Come on, man. All right.
At least it is these questions.
So if you got
Dude,
any
I ask the
questions,
best
fire up
questions.
over there.
Do you ask a lot of questions?
No, he doesn't ask any. Oh, I don't ask any questions. It's
Do you?
paid for. It's important.
All right. Let's go ahead then and pass the mic to Beige.
Someone's like way down
Or
here.
Beige,
Yeah, I know.
as it were. No Evan Bronson? Oh, it is Evan Bronzy, Clear Creek won the rights to your contract in a battle with Regina last night. So
Hey,
you're going to Clear
Crouch.
It was a close game.
Get on yours.
All right, so ours is the same as 2A, except there's friction on it. So it's the same on the first one. On position A, there's not going to be any gravity or elasticity, but since it's moving, there's going to be motion. So, and then you go to position B, and then there's not going to be any motion on it, but there is gravity, and there's no elasticity. But since it's moved up to the top of the hill, there's going to be dissipation on it. So
Okay. So here's the audience participation part, and I would like to see you in on this because I do see who's writing what back here. So what's the consequence of this? There's friction now. So these lads are showing you. It starts off with the same EK, but now in the end you have one block of E-dis, so you only get one block of EG. Okay? So in plain wording, explain to a 5-year-old what's different about the situation for the car here as it goes up the hill. Okay? What's different about the consequence for the car, if you will. Okay? So take a moment over on the ZFOXW. As a consequence of this friction, what's different about the situation? Ooh, let me snag my Chromebook. I'm up there quick. Cheers, buddy.
I got you.
Okay.
Hey, Nada.
All right, a few of our friends ran back here. Let's see what to say. Ooh, question for you. Why isn't there gravity at A?
because it's frictionless.
No, that was from you.
And this
Oh, never
question
mind,
can
never
go to
mind.
the
I was-
red group as well, because you have the same thing. Why don't you have any gravity at A? Okay, so there's the response to that first question. It's at the lowest point on the hill. It's not going to go below there. The drawing kind of makes it look like it could maybe, but we're choosing to say that's the lowest position. And I'm going to come back around to this idea of EG blocks later, but for now that'll suffice. Okay. And then our friends are writing in here, the car doesn't go as high, so there's less potential energy. I think they mean injury from the gravity. Okay. Hayden said, hey.
Hey, man.
Energy is leaving at 2B because of friction. Did it leave? Where did it go?
What?
Still there, right? But where is it?
Oh, which one?
2B there? Where did the
Oh,
energy
yeah.
go? It didn't leave. You have some EG and you have
There's some dissipated.
some
Probably in
dissipated.
the like
So
heat.
it's
energy
still
or something.
there, it's just dissipated. That means it's warmed up the surroundings or it's made some sound or something like that. Okay? Cool. All right, thanks. Go ahead and slide it up to the next one. Let's see who's next. Periwinkle. Coming up with that 3A.
Looks like our board's just whole leg.
Oh, ew, we have to go.
We're right.
Are we?
I don't know.
So,
Maybe.
we could be very wrong. Yeah.
Do you want me to explain?
Oh, yeah, sure.
Oh,
Let me see it. Let me see it. You know what ketchup right there?
just go over to him. I don't know if I read it.
Hey.
Yeah.
So I'm free.
So he needs to be in that group next week.
All right, Zach's going on here.
Okay, so the problem says that a person is pushing the cart up the hill with a parking brake on, and we're supposed to assume that the system consists of the car, the road, and the earth. So there is no spring pushing the car, and it is at its lowest position, so there is no gravitational injury, and then there is no motion. But in order to get the gravitational injury in position B, the person has to do work. And then there's also dissipation due to friction with the parking brake and the surface.
And so how much work is the person doing here?
3 blocks
Okay.
worth.
So this word work in a business context just refers to energy transfer or change in energy. Okay. The person is transferring energy into this car, road, earth system by pushing the car up the hill. And that's going to make the car dangerous because the car could roll back down. Other cool, let's see here. New question. Other questions for this group. And again, kind of like I appreciated greatly that question in the last one about why was there no gravity at A. We're just learning how to do this stuff. You probably have legitimate questions on, well, why are they doing this thing? You didn't do this problem. So if you don't understand why something looks the way it does, this is a great time to ask. And if you do it via Pear Deck, it's kind of anonymous unless you put hey at the end of it, and I know it's Hayden.
This one?
Yeah.
Who's
EG person is.
It's on.
Yeah.
Awesome. We're getting great questions. I'd like to hear from a few other folks that are looking to do well in the quiz Friday. All right, so we got one here. Wouldn't there be just a little motion at the beginning?
We're given in the problem that the velocity of the car at position A is equal to 0.
So that's what's going on here. I think in reality, right, we see the car moving a little bit, but the L on the chart shows the velocity is 0, and so that's their excuse for putting an X there for EK.
Yeah.
All right, and then we've got, is working person okay to be in the equation instead of an energy like E something?
We kind of just put working person since we don't know what type of energy the person is putting into the.
And I don't have the sheet with me. Is the person in the system or not in the system?
They're not.
They're not.
They're not in the system. And so this is kind of what establishes that it's going to be working because the energy is coming from outside of the system to in. And so how you label it is like they've got there. What's it coming from? Person and work because it's working into the system. And I have a feeling we're going to talk about this next as far as like what do we call it if the person is in the system.
Yep.
All right, let's see what else we got here. Looks like, how do you make how do you make the formulas at the bottom? What is B?
So B is the basically at position B. It's the gravitational energy at position B, and it's the dissipation, energy dissipation at position B.
So it's just a way of noting these things so we know which of the two locations. Right now we just deal with two locations, position A, position B, a little farther up the hill. So the subscripts are telling you energy at what position. Excellent. That was great. All right. So I think we're good then. Let's go ahead and move on to Gray with an A.
All right, so ours involved with a person, Sec 3A, but only it involves a person this time. And what we found was that the energy was stored in like the man pushing the car up the hill. And so we made EChem to stand like, that's what EChem stands for. And we had 3 blocks of those. And then on the in position B, we had 2 blocks of gravity and then one block of EDOS.
And if you need to slide that over, you can a little
I
bit.
don't think it slides. Oh,
I didn't know that either.
All right. Questions for Gray with an A? Got a question for you here. What is ECAM?
Ecam's like the energy stored like in the person like that is pushing it, I guess, or that's like holding it.
Okay. Yusuf, how is that energy stored in the body?
ATP.
ATP. Okay. So you eat some food. That food eventually is stored in your muscles as ATP.
That's easy.
And then when you do stuff, that energy that was stored in your muscles now is stored gravitationally in the car or dissipated by. Why do we have dissipation again?
Because so we had 2 blocks of EG because it could fall on you and hurt you, and then there's no electricity and there's no motion, and so we added 1 block of dissipation because it's like
I think it's because the
Friction.
parking brakes are on, so
It's like
it creates
friction.
like thermal.
or
Got you.
that.
Okay, so there's mention that the brakes are on. Anybody have a car where you have to regularly use the parking brake? Is that anybody in here? Nobody?
It's
Josh?
not. We have one in the family, but
What whip you pushing?
an MG midget
Oh my gosh, what year?
like 70 something I think.
Chrome bumpers?
Yeah, no,
Rubber bumpers?
Yeah.
It's pretty sweet.
Yeah.
You used to drive it on occasion?
on occasion, not that often.
When it starts,
But, well, right now we have the motor out of it, but
fair enough.
we have to rebuild it.
Give me a shout. I can do it with the wrench. I love British
Right.
bikes. So yeah, like my pickup truck is a stick shift. So I have a parking brake that I have to set if I'm on anything other than a completely flat surface. And sometimes when I take off with the parking brake on, I don't notice it right away. But then the first time I try to coast, my truck slows down really quickly to a stop. Because it's basically like having a slight brake pedal at rest the whole time. And that's just going to turn all that useful injury into thermal injury. All right, let's see what else we got here. Would the person's pushing force be EE since it's kind of similar to a spring pushing the car up the hill?
No,
Why not?
Big block.
I don't know. It's just not.
Because there's no
spring.
there's no rubber band. So it's a different form. There's a lot of forms, and so it's okay if we need to like invent one and add it in on occasion. That's totally cool. All right, go ahead and scroll here. Let's pass the mic to Sunburn. And you can pitch zoom that a little bit better so we can see your board if you like.
Okay, that didn't go back.
All right, Sunburn, what the heck's going on in this problem?
So there was a brick resting on a spring and then it was launched into the air. We're going to assume that the system includes the spring, the bricks, and the earth, and our problem does not have friction in it. So we said that there's no motion in the first one because that's on the spring, and then there's some gravity because it's not on the earth. And it's on a spring, so there's a lot of elastic, whatever. And then position B is there's some motion, but there's way more gravity with that. Yeah.
Will you show us your equation?
There you go.
All right, so these all appear to be kind of getting at the same thing here. Should there be gravity at position A since it's already as far down as it will go because the spring is all the way pressed down?
Sure. Sure. Probably.
Probably what? There should be EG?
Yeah.
So here's the thing about these mold charts then, it comes down to logic and plausibility. Is it plausible here, the answer that they have? What happens to EG in moving from position A to position B?
Gets bigger.
Gets bigger, okay? So whether they go from 2 to 3 or 0 to 1, it gets bigger, okay? And that's what matters. And this is an important conversation I want to have because I'm going to do something weird with this a little bit later, okay? And so just know this right now, that the choice of how much EG you put in there is kind of arbitrary. The important thing is, as they say, it gets bigger, so we know it goes up vertically, okay? Questions on other things here. What else do you have? All right, looks like that's it. Go ahead and slide it over. What's the next board? Wow, perfect. My job's not so easy, huh? And so yeah, if you didn't catch it there, so the equation goes EGA plus EEA equals EKB plus EGB. Why do you guys have EK in B? Superladze in B?
In B,
Yeah.
I don't know. I accidentally.
I don't know this is I'm just asking. What does it tell you in the problem that tells you there's an EK?
There's motion.
There's motion. It's moving. It says velocity is not 0, correct? Yeah. So there you go. Perfect. All right. Let's change stuff before we get chased.
Yeah,
What are you doing?
because I misread it before.
Oh, that's
where-
the fun part.
It says at the top. So this is the same thing with friction.
Okay.
And so I misread it as B being at the very peak where it would have no velocity, but instead it does. So it does have EK.
Dang it, Brody. That would have been a good question.
Yeah.
Oh, well.
Too bad.
Okay.
So
ruined our fun.
EEA equals EG at B plus the friction plus EK at B.
All right. Questions or concerns for this? Is it supposed to be the same as 4A, but with friction?
And the different number of blocks, but whatever.
So given that A and B are supposed to go together, there's a couple logical questions that you should be asking. That's what I'm looking to see show up.
Looks good to me.
Everybody's talking about something.
All right. Let's see what we got.
post it.
So first one, would there be a force from gravity in position 1?
It's as we've established, it's at the lowest point it's going to be at, and it says actually the height at A is 0, and so I'm basically interpreting that as there's no energy from gravity at that point.
Here's why I really like this question, because it's asking about force. Is there force from gravity at that position?
There is, but it's countered by smoosh push from the spring, so it doesn't really.
Well, and it also gets at what we're representing here. Are we representing force here?
No.
This is
Energy.
energy. So understand that, okay? So yeah, there's definitely gravitational force happening at this location. But in terms of the potential for injury, if it can't fall, that's their justification for saying that. That's this group's justification for saying that there shouldn't be any EG listed there. Now, if these are supposed to go together, which I'm pretty sure the bald, angry old man said that they needed to be consistent with each other if you were working on the same number problem, then shouldn't both of them be the same since we're only adding friction? Because here's the other problem now. How much does EG change for 4B?
So EG goes from 0 to 2, so that's +2.
They're going +2. The other group went
+1.
+1. Why is that problematic?
Because it's implying that, because more EG means more height, and because there's friction in 4B, it wouldn't go as high, yet it somehow has more energy.
A bigger change,
Yeah.
right? So how do we fix this?
Make a bigger change in gravity in 4A.
Okay, do it.
So let's make that. So I'm going to. That should still equal out, right?
So now, hold on, did we go the right direction?
Yeah, so
Change
that
from 1 EG to 3, so that's a change of 2.
could get. Let's see.
And for yours, yeah, you can fix this. Put a block of EG on his at the beginning.
At the beginning,
Do it.
that isn't working.
Is the pen not working?
Yeah,
You can use the other pen
where's the other pen?
on the side. A little bit easier.
There it is. So then we'd add that at the end.
Ooh, but now we have a new problem.
Oh, yeah. Wait. Add that at the end. We add that. Same.
So what's the problem right now, friends?
It's not balanced.
It's not balanced. So somebody come up with a way to balance it on the pair deck. Help out the Brodies. Max, is your middle name Brody?
No,
What's your middle name?
Lee.
Maxwell Lee. There we go. MLS. Dude, you just have like a bunch of like MLS t-shirts at home. You know, do you want some? I have some I don't wear, so there you go. You've got your initials on them. Come on, man, get on the pair deck. How do we fix this? So right now, there's 1 block of EG at the beginning and 4 blocks of EE. In the end, there's 1 block of EK, 2 blocks of EG, and 1 block of EDIS. So that's a problem.
Wait, just add the
5
one.
doesn't equal, I don't know, they'll help you.
All right.
5 doesn't equal 4. So suggest an easy change. Whoop. Add a block of EDIS or EK. Add a block of EDIS. Add 1 block to either EK or EDIS. What do you want to do?
Added one to EDIS.
4K.
4K. It would, then it's 5 and 5, and then, let's see, 5 and 5, and
You have
It wouldn't
less
go-
EG than 4A, and you have less EK than 4A.
Yeah.
Those justifiable.
yeah, because you have the friction this time, and that's EDIS.
Cool. Awesome. There was a lot to take away from this one. So if you've got your sheet handy, kind of make sure your sheet agrees with what we're talking about here. So in the end, what's your equation?
It would be EE at A plus EG at A equals EG at B plus EK at B plus EDIS.
Can you add in that plus EG at A there? This is going to be for all time on the internet. I think that takes care of it. Go ahead then and pass the mic. 4C, gold. Sorry, lads. Now it's really compounded.
So our problem is the same as 4A and 4B, except it says take away the spring.
Yeah.
And so we're gonna have to add gravity right here.
Oh, you got it.
And to even it out, the working spring is gonna be 2 blocks. And so we're gonna have 3 blocks in position A. We're gonna have 1 block for gravity and 2 blocks for the spring. And position B is just gonna be EK and 2 blocks for E gravity.
All right. Can you be a hero and slide that over so you can see all 3 of the whiteboards at once? Thank you. So kind of take a look at what they have. I think independently theirs is fine, but if they have to be consistent with the ones they have to be consistent with, look at what it says on the sheet there. As far as friction, as far as everything else. Are there any recommendations or changes we would ask them to make so that all these are consistent with each other? Uh-oh. So here's a question for you. Would EKE and 4C have to be the same as 4A since both don't have friction?
Yeah.
So go ahead and fix that. Fix is not the right word. Go ahead and change that. Your answer is fine, but if it has to be consistent with the other boards, we got to have 2 blocks of EK. Alright, and then for the same reasons, can you fix that? Can you change that EG so that it also is alike to 4A? So I think we need 3 blocks of EG. Alright, so now your B looks exactly like the B for problem A. So we're cool there. What do you need to change about your working arrow to make this problem be okay?
It's gonna be 4 blocks.
Yeah, go ahead. So we have 1 block at position A. We have 4 blocks of working. Now we have 5 blocks in the air. So I need you to consider the math here and see if there are any changes we need to ask for their equation. I'm not going to let them do it. They can probably already see what they need to change. But can you out here in the peanut gallery see what they need to adjust there? Peanuts. All right, let's see what you're saying. Gotta add EGA to the equation. Because we gotta get this to add up to 5, right? So EGA is 1 plus working spring is 4 equals the 5 that we get from the other ones. All right, perfect. That's fantastic. You guys are doing great. All right. Thanks, lads. Go ahead and slide on down. Let's see what's next here for 5s.
Yeah, I'm waiting for her to take the question.
Oh, such a joke.
Thank you, Yusuf.
All right, green popping up. I agree. What the heck's going on here?
So it's at the bottom of a hill with a spring, and then when the spring goes, it gets propelled up the hill. And so it's on Earth's surface the whole time, so it has no gravity. And at position A, it has elastic energy, and at position B, it has motion energy.
All right, questions or concerns from friends here. What's your equation say there? So elastic energy at A equals kinetic energy at B. Any questions from our friends?
This isn't right. Yeah, this isn't right.
This is a
Yeah, no, that's not gravity.
All right, question for you here. Got this frozen. All right, no EG?
No, because we said it was on Earth's surface the whole time.
On Earth's surface the whole time. All right, looks like that was it. Go ahead and pass the mic. Who's next? Rick Wass. All right, so what's different?
Well, you don't have the spring, and so you would have to have a working force, and then so there would be EK and EDIS in B.
So what's the consequence of the? So why is it different? Why is B different from the other board?
Because there's friction
There's
too.
friction. There's no spring initially. So, and I want to mention this too, just because of how some of the questions are written. There is a spring, otherwise nothing happens. We're just not including it in the system. Kind of like that person earlier that was pushing the car up the hill. So there's definitely a spring there, but the energy that's stored in it doesn't count towards our total initial emissions, which is kind of weird for the problem, but there are other situations where that's going to be a reasonable thing to do. All right. don't see any other questions, so we'll call that good there. Let me introduce you guys to this thing. So if you want to kind of slide back here, uncomfortably close to Emory. I'll dig this thing. All right. Come on, let's get uncomfortably close to Emory. Especially the not punk is see what's going on. All right, so rainbow rings. Good. All right, so I've got 4 balls here. Hey, you okay, the ball bearing. Thank you. All right, so I've got 4 ball bearings here. Okay, I'm gonna let them go down the ramp, and set that wrong. I'm gonna start them at the same time. Is my cheeky way of starting this. So I've got 4 ball bearings here. I'm gonna start them at the same time. Which one's gonna hit first? Red, green, yellow, or blue? All right, so votes for red, votes for green, votes for yellow, votes for blue, votes for the same time. All right, you ready? 3, 2, 1, go. Screwed it up though, so I set down the ramp, so 5 there. I didn't say there. Whatever. All right, my bad, Joe. So they all at the same time. Why? Because gravity, right? Okay. Oh, you want me to let them go? Okay, so sorry. So same thing, right? Okay, you're gonna go. All right, so let's watch it. But I need you to watch it carefully. I need you uncomfortably close to Emory because there's something that's gonna happen over here that's gonna tell you a little bit about their motion. Okay. So you're saying blue's gonna go first, and we gotta like process it, edit it. If we just watch it in real time, that'd be so much better. Yeah, somebody wants a slow-mo video of that. All right. So, not watch them when they hit the ramp, but when they hit the floor. Okay? Because it's like there's some foreshadowing, like there's some strikes down there. Those are all about. Ready? All right. Dame las bolas. Don't hit somebody's cell phone. 1, 2, 3. All right. So again, it'd be super cool if you're close enough to see them land on the floor. I don't want to give away all the fun. What do you notice about how they land on the floor? Okay, ready? 3, 2, 1, go. You're right there. You were staring at me the whole time. Right? Did you watch them? What did you notice about where they hit? They hit the same spot. They hit on that strike right there. What does that tell you about their motion? Run it by your neighbor real quick. Look at you. Like, they don't all hit at the same time. Blue hits first, but they all hit the same spot on the floor. What does that tell you about this setup? They all hit the same spot on the floor after they leave their ramp. What must be true of all? Same speed, says part. Find that? It's a projectile motion problem. They all come off the ramp at the same height. They all hit the floor at the same spot. They must have the same speed. If one was going faster, it would land farther away, but they all landed at that spot. They all have the same speed. They all have the same speed and they all have the same mass. What's true of the potential for injury stored in their motion? Right? So if we put Chase's toe here, ouch, 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 ouch. Equally painful. Okay? They all have the same pain stored in their motion. They all have the same pain stored in their motion. Where was that pain stored originally? Run that by you. Where is the potential for injury stored, or how is it stored? What is the mode of storage here? These things are moving. Why? Because that's what I need you to make supposed to hear. Springs, rubber bands, chemical. How is the potential for injury stored in it? What do they do that makes it move? Which? Let's part through all the heavy lifting. Okay? Talk to your neighbor here. Why? You don't have to use like words like injury here. Why are they moving with the game? Why do they have the speed they have? Even better, why do they all have the same speed that they have when they get down there? What the same thing leads to that? What about the ramp? The ramps are all different. In what sense of it? Because if I'm looking at this right now, yellow to me looks short, right? It's straight like that. In what sense are they all the same? Well, again, I'm going to say this one travels the least distance, right? From A to B on the yellow one. So what do you think is going to be more important here in terms of gravitation, the x or the y-axis? And how does the y-axis change for each of these? Same. They all fall the same vertical distance. So that's why they all end up with the same injury stored in the motion at the end. Because by following the same vertical distance, it doesn't matter that which one actually travels farthest. Blue or red probably travel farther. But they all travel the same vertically. They all experience the same change in height. So they all have the same amount of gravitational injury that goes into kinetic injury. Okay? And again, that's evidenced by the fact that they all land at the same spot on the floor. So they must have the same speed when they okay? So I need you to have that understanding that, yeah, when that thing falls, that's a consequence of a change in gravitational entry. But this thing rolling down a hill, I mean, how is the injury stored here at the beginning? It doesn't fall in a sense, but it does fall at an angle, right? It's kind of going down this hill. It's changing its vertical level. That's EG. So we're going to come back around to this one. Although actually I've got one that you said. So I want to say here, because as I'm looking at this, what's happening here to this thing? It does what vertically? It goes up, doesn't it? So for that reason, I'm going to say that there's a change in EG. I'm going to give it 2 blocks of EG here. Where did that EG have to come from in this problem? Because right now, I've got 2 equals 4. What do I need to change here?
Is this 6A?
This is 5B. Uh-oh, who knows? Well, we'll pick up there tomorrow.